All right, continuing our notes from yesterday, Unit 9, Topic 3, the models. Today we're going to do the interest rate models. So in the notes, we're on page 18. And this one gives you interest rate for savings. If you deposit money in a bank, how much interest does it grow each year? So there are different amounts, or there are different equations for interest rates. This is the one that we use, but depending on the banks, they have different formulas as well. All right, so labeling this stuff. It says at the top, consider an initial principal, P. So P is the principal amount, which is your initial amount. So that's how much you start with. And then it says, is deposited into account that pays an annual rate of R expressed as a decimal. So R here is your rate, your percentage, but you need to change it to a decimal. Compounded n times each year. So n here and here is the number of times it's compounded in a year. Number of times compounded. So this is the frequency, is basically what it's asking. How often is it being compounded? How often does it take your money, multiply it by the interest rate, and add it to your savings in a year? So does it happen once a year? That would be annually. Every month? That would be monthly. It would be 12 times a year. So it depends what the frequency is, what these two n values are going to be. And then T is your time in years. The A value, that's your final number. That's what you end up having in your bank account at the end of the year. All right, so example 8, you deposit $2,900 in a bank account that pays 3.5% annual interest. Find the balance after 5 years if the interest is compounded annually first and then monthly second. Now, these interest rates, they're pretty high. Usually they're 1% or less. But we want to see a growth, so we're making them a little exaggerated. All right, so how much do you start with? The principal amount is the $2,900. So that's what you're going to plug in for P. The rate is 3.5. So if I move the decimal back twice, multiply it by 100, it's 0.035, not 0.35. That's only moving it back once. Make sure you move it back twice. And it says find the balance after 5 years. So time is 5. The only thing that we're going to have differently here is the n. So for annually, how many times a year is annually? That's 1 time a year. So we're plugging in 1 for n for annually. And monthly would be how many times a year? How many months are there in a year? Would be 12. So write in the formula out, and then we'll plug it all in the calculator. So P is 2,900 times 1 plus R over N would be 0.035. 0.035 over N is 1, which we really don't even need to write because anything divided by 1 is itself. And in the exponent, we're going to multiply the number and the time. So the number is 1, and we're going to multiply by the time that it wants, which is 5. So from here, I'm just going to type all of this in the calculator and get my final balance after 1 year. So grab your calculator, and I'm going to do 2,900 times 1 plus, technically you should put parentheses around this fraction, but order of operations is going to make it do that part first, so we really don't need the parentheses here, divided by 1 to the 5 times 1 is just 5 in the exponent. and we press enter. And we're talking about money here, so we round to the nearest cent. So we have how much in our bank account? We have $3,444.29. So I wouldn't do this individually because sometimes this is a very ugly decimal. Or, I'll show it with part B. Part B, you're going to see why you don't want to do it individually as a step. You just want to type all of it in at the same time. All right, so for part B, everything's the same except the N is going to be 12. So 2,900 times 1 plus R is still 0.035. But this time we're going to divide it by 12. And the exponent's going to be raised to the 12th. And I multiply it by 5. All right, so if I type in everything first to begin with, 2,900 times 1.035, 035, divided by 12 to the 12 times 5 exponent gives us, now you would think it would give you a lot more because it's compounded so often, but because you're dividing and raising it to the power of 12, it's actually not much different. It is different. It's more, but not by like thousands of dollars. So we get $3,453.73. So the reason I say it's better to type it in all in at once, you would do the parenthesis part first if you're doing order of operations. So 1 plus 0.035 divided by 12. You get a number that if you were to round it, it would round to 1. And that number, if it's 1, it's not going to change. It would be the 2,900 always. So you can take that, and then, yes, you can raise it to the 12 times 5. And then you can take that and multiply it by the 2,900 if you prefer to do it that way. But it is important that you do not round the base, because the base rounded is going to round to 1 usually, and that's not going to make our answer different. All right, so doing the bottom part. So I'll do this one, and I'll have y'all do example 10 on the next page. So looking at number 9, it says you deposit $4,000 into account that pays 2.92% annual interest. Find the balance after 5 years if it's compounded quarterly and then daily. So again, the initial amount is the 4,000. The R value is this. As a decimal, we would move it back twice, 0.0292. And the time it wants is 5 years. So quarterly, how many quarters are there in a year? There are 4 quarters. Now I know that's every 3 months, but in a year, how many times does it happen? It happens 4 times. So quarterly is 4. Daily, we'll say in a regular year, is 365. It will not make a difference if it was 366. A little difference, but not enough to change the amount that we're going to get. All right. We do A equals P is 4,000 times 1 plus R is 0.092, or sorry, 0.292. 292 divided by N is 4. And then we raise it to the exponent. Multiplying N and T is 4 and 5. And we type it in the calculator. And go ahead and type it in the calculator. And here we'll get $4,626.33. So make the equation for B, set it up, plug it in, and tell me what the value is. All right, so from the last problem, you should have got that the daily amount was $4,628.76 if you round that one. So we're going to do the same thing here. We'll set them up, and then you can type them in the calculator and evaluate them, and just checking with your group to make sure you'll get the same answers. We'll set them up and you can type them in. So for all of these, we're saying that the A value or the P value, the principal amount is 2,200. So 2,200. R is the 3%, so 0.03. Move it back twice. And then we want to find the amount for 4 years for all of these. The only thing that's going to change is the frequency at which we compound it. So for the first one, annually would be n equal to 1 because it's only compounded one time. So B, semi-annually is twice a year. So n is 2. Quarterly, 4 times a year. Monthly, 12 times a year. Weekly, how many weeks are there in a year? 52. And daily in would be 365. So for all of them, we want to set this up. The only thing that's going to change is the frequency. So I'm just going to set one of them up, and then you can do the rest of them. So for annually, we do 2,200 times 1 plus R is the 0.03 divided by annually is once a year times NT. N would be 1 times T would be 4. So for this one, we type this in. And really, if you just want to take this and just put an X, or I guess an N here, N and N, it's going to be the same equation for all of them. You're just plugging in different numbers for N. So you can copy and paste in the calculator. So 2,200 times 1 plus 0.03 divided by, in this case, N is 1, to the 1 times 4 exponent. So for N equal to 1, we get $2,476.12. 11.9 rounds to 12. So here, if you do second enter, it'll copy everything. All you got to do is go change the N in the exponent and the N in the denominator. So this one will change to 2, and this one will change to 2. For semi-annually, we'll make a little bit more. So here, for the semi-annually one, we get $2,478.28. So you go through all of these slowly. They'll go up, go up, go up. But as you get to the end, it's going to be pretty much the same with like 7 cents difference. Okay, so find those once we finish this bottom part right here. Actually, just go ahead and find them. I'll give you a couple minutes there. All right, so as you can see on the previous example, as the numbers get bigger, the Y value gets closer and closer to a certain, it doesn't keep going up forever. So we could have done minutely, we could have done secondly, which we're going to do here, hourly and minutely. And we're going to see that it's actually not going to change very much. So notice above that your account will not continue to increase, even though the number of times it is compounded continues to increase. This is the limit of the function. So that's a calculus word right there. So let's see what a limit actually is. So here, we're going to make everything ones so that it stays pretty much steady. And the only thing we're going to change is the number of times that it's compounded. So here, annually means we compound once a year. Semi-annually is twice a year. Quarterly would be 4 times a year. Monthly is 12. Weekly is 52. Daily would be the 365. Now for hourly, how many hours are there in a year? Well, we take the 365 and multiply it by 24, because there's 24 hours in a day. 24 times 365 is 8,760. And then to get the number of minutes in a year, you take that number and multiply it by 60. So we could do secondly as well, multiply that number by 60. But we'll see it with this one right here. So this times 60 is 525,600. Multiplying each of those in order. So now what we're going to do is we're going to take that number and plug them in for ends. So I'm just going to copy paste like I was doing earlier with this formula. So 1 times 1 plus 1 divided by, the first one is 1 to the 1 exponent. And we get 2 there. I mean, we could have figured that one out, but we'll just put it as 2. So now I'm just going to copy and paste and change the exponent and the denominator. So then the exponent becomes 2 for the next one, and 2 for the denominator. Oops, 2. And here we get 2.25. And continuing, I'm not going to write them all, but I'll get them on here and you can just copy them. Changing this one to a 4, and this one to a 4. 2.44. Changing it to a 12. And this one to a 12. 2.61. I mean, more decimals, but that's enough. Now 52 for the weekly, 52. And then change the denominator to a 52. 2.693 if we go all the way to 3 decimals. And then going to the daily, 365. And over here, 365. Oops. What did I do? Oh, I forgot the parentheses. So 2.7145. So here, keep it at 3 decimals. 2.715, you can round it to. Because now it's going to start getting very close to each other. So 8760. And then over here, 8760. Make sure I close my parentheses this time. 2.7181 is what this one is. And you should start recognizing that number. So 0, 0. And then go change this one to minutely. 5256. And we get, I didn't put my parentheses again. 2.718279, blah, 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 blah. So notice this part is the same from before. So before the error, 2.718, 2.718. So that number we saw when we were graphing last week. And it is the number 2.71828 ... This number is called the natural base. And we write the natural base with the letter E. So E is a number, very similar to pi. So these, I know it looks like it's starting to repeat, but it's never going to be the same over and over and over again. It looks like it's 2828. But if you go further on, it doesn't continue that. So here, remember the E number you do the second button, and then you do the divide button, and that's where you'll find the number E. So at the bottom it says the natural base E can be treated like other bases. All the properties of exponents, transformations, and graphs act the same way. So we'll do a little bit more operations on Thursday with E. I want to do the last formula today. So let's do the E formula, which is PERT. I call it PERT on page 21. So we use PERT when it's compounded continuously. Continuously means every second of every minute of every hour of every day it's being compounded. So an infinite amount of times, but when it's infinity, it's that limit for E. So that's what the E is here. So E is the continuously part. The P is the same as it was before, your principal amount. The R is now part of the exponent. So the R here is your rate as a decimal. And the T is your time in years. All right, so example 14, you deposit $3,500 in an account that pays 4% annual interest, compounded continuously. What is the balance after 5 years? So because it says that continuously, I know I'm going to use the PERT formula instead of the compounded interest formula. So P is the 3,500. So 3,500. I know I'm going to use the E because it's continuously. And in the exponent, I multiply R and T. So R is 4%, which is 0.04. 0.04 times T. And it wants the balance after 5 years. So T is 5. So times 5. So now we can just type all that in at once. And you could do the minutely one, but why type all that in when you can just do E? So 3,500. Second divide is the E button. And then for the exponent, you put 0.04 times 5. And we get that the balance would be $4,274.91 if we were to round it to the nearest cent. All right, so the other way you can get the second divide is just the number E. If you want to automatically make it as an exponent, it's second ln automatically gives you the E with the exponent. So you can also do it that way. So I'll do it that way this next time. It's shorter, you don't have to do the caret sign, but it's the same E. All right, so for 15, so I'll do 15, and then 16 is with the graph. So it says you deposit $4,800 in an account that pays 6.5% annual interest compounded continuously. What is the balance after 3 years? So this part's still the same. The $4,800 is my principal. So $4,800. 4,800. I know to use the E because it says continuously. If it didn't have the continuously, it would say annually or daily, and that means I use the other formula, NT. All right, my rate, 0.065, because I move it back twice. Multiply by 100 is 2 decimal places, so 0.065. And I'm going to multiply that by T, which is, all right, so last one got cut off. So looking at the answer for this part over here, we did 4,800. Second ln is going to give us E with the exponent, 0.065 times 3. Gives us that the balance would be, after 3 years, $5,833.49. All right, so the last one is using the calculator to find the intersection. So it doesn't really help us by labeling it, but we can reason through what these numbers are. So here You deposit $700 in an account that pays 2.75% annual interest. How long does it take for the balance to reach $2,000 when compounded continuously? So I want to know, so I'm going to put the 2,000 here because that's what I'm looking for. And I want to make my equation over here. So my A value is 700. And I know to use the E because it says continuously. And in the numerator, I'm going to multiply the exponent, I'm going to multiply the percent, which is 0.0275. And I don't know T, that's what I'm looking for, so I'm going to make it with an exponent of X. So on this graph, this one actually isn't 0 to 10 because in order for it to grow that much, it needs to sit and collect money a long time. So it is going to start at 0 here. But then these don't count by ones this time. We need it to go all the way to 50. So these look like they count by 5s, 5, 10, 15, 20, 25, 30, 40, 45, 50. Because it's going to take quite a bit of time for it to, maybe not 50 years, but it's going to take more than 10 years. So we need to make it a little bigger. All right, so this is my starting amount, 700. And it looks like it's just above that one, so that one's probably 500. This is 1,000, 2,000, 3,000. It looks like it goes all the way up to 3,000. So if we draw the horizontal line of the 2,000, it would be 5, 1, 2 would be right here. That's the point of intersection that I'm trying to find. So let's go adjust our window and graph it in the calculator. So over here, the y equals, let me clear this last one. We want to do 700 e to the 0.0275 times x. And we want to know when does that reach 2,000. So if we graph it, if we just hit graph, it's probably not going to be the window that we want from before. So I'm going to go through and change it 0 to 50. And again, it's counting by 5s, and that really doesn't make a difference when you graph it. And then on the y, it's 0. And the top number is 3,000, because you always want it to be higher than what you're looking for. And this one counts it by 500s, but again, without the scale, it'll still graph it for you. So this is the graph that was given. Here comes my 2,000. And to find that point, we do second trace number 5, enter, enter, enter. And we get that it takes quite a bit of time to increase that much. So time is 38.17 years. And that's with a pretty decent, pretty big percent rate. So hopefully you would be adding along the way. If you have this in the savings account, you won't just let it sit there at 700. But even at 700, you still get money. It just takes a long time. So more than almost triple your money. All right, so that's it for the 4 models. So in the end, I will give you the 4. You just have to know when to use them. So when do you use the 4 models? PERT is when it's continuously. We'll come back to that page. The compounded interest is when it gives with a certain frequency. And then the growth and decay, you have to know whether it's saying growing or decaying for population or for cost. All right, so now you can work on your homework, finishing the one for tomorrow. If you're done with that one, then start the new one.